Morning students. So we have studied about the preliminary treatment of sewage. Okay. So next treatment is primary treatment of wastewater. Okay. So after the preliminary treatment, next stage is primary treatment. After that we are doing biological treatment. Okay. So primary treatment of wastewater is a plain sedimentation process. It is actually plain sedimentation process, and this primary treatment is carried out in order to remove suspended organic solids which cannot be removed by preliminary treatment. Okay, so usually by preliminary treatment we are removing heavier particles only. Okay, we cannot remove suspended organic solids whose size is very much low comparing to the heavier particle. So that particle will be removed using plain sedimentation process in primary treatment. Okay, so for this we are sometimes using chemicals in order to remove this finely divided and colloidal solids. Okay, so that is primary treatment, that is the materials which is not removed by the preliminary treatment, that will be finely divided and colloidal solids. It will be removed using primary treatment process. Okay, so this primary treatment is usually plain sedimentation process, and this primary treatment carried out based on the principle of theory of sedimentation, and I think you have studied this theory of sedimentation and plain sedimentation in your water treatment. Okay, the mechanism and principle is same as that of a water treatment process. The settling of the particle in sedimentation is due to gravity, and the settlement of particle in water brought to rest, it will be opposed by some parameters like velocity of flow, which will carries the particle horizontally. So this velocity of flow which carries the particle horizontally will prevent the settling of the particles in sedimentation tank. Okay. Also the viscosity of water in which the particle is traveling, that is warm water will be less viscous and it will offers less resistance to settlement, and if viscosity is high it will offer more resistance to the settlement. So that is another factor which resists the settlement of the particle. And the last factor is the size, shape and specific gravity of the particles. That is, greater the specific gravity, more readily the particle will settle. That is, if the weight of the particle is very high, it will settle fastly. Okay, like that, greater the specific gravity, more readily the particle will settle. So these are some of the factors which are preventing or supporting the settlement process of the particles. So next is primary sedimentation tank, and this primary sedimentation tank is also known as primary clarifier, and it is located just after grit chamber. That is, the particle which is not removed in the grit chamber is passed into this primary sedimentation tank and is removed by the theory of sedimentation. Okay, and that is, the sedimentation tank is designed to remove a part of the organic matter from the sewage effluent coming out from the grit chamber. So that particle is removed in sedimentation tank, and the sedimentation tank may be rectangular, circular or square in shape, and usually at sewage treatment plants this sedimentation process is carried twice. That is, one sedimentation is done before the biological treatment and one process is done after the biological treatment. So in usual process, this sedimentation is carried out twice, one before the biological treatment and one after the biological treatment. And sedimentation process before the biological treatment is called primary settling, and the sedimentation which is carried after the biological treatment is called secondary settling. Okay, so this primary sedimentation will be carried out before the biological treatment and secondary sedimentation will be carried out after the biological treatment. Okay. And in the process of sedimentation, the velocity of flow is decreased to such a value that finer settleable will settle to the bottom of the tank. That is, if the velocity of flow is decreased, the finer settleable materials will be settled to the bottom of the tank. This velocity of flow can be reduced by increasing the length of the travel and by detaining the particle for a longer time in the sedimentation basin. So when this time period increases, the smaller particle also will settle at the bottom of the sedimentation tank. Okay, so such settling tank in which sewage continuously keep on moving with predetermined velocity is known as continuous flow settling tank. That is a type of sedimentation tank, that is continuous flow settling tank. Okay. And the liquid sewage which is coming out of the settling tank after the process of sedimentation is called effluent, and the settled viscous sewage at the bottom of the tank is called sewage sludge. That is, the material which is settled at the bottom of the sedimentation tank is known as sludge, sewage sludge. and the sewage or the liquid sewage which is coming out of the settling tank after the process of sedimentation is known as effluent. Okay, that is, effluent means it is the liquid waste coming from the sedimentation tank after the process of sedimentation, plain sedimentation, and the material which is settled at the bottom is known as sludge. Okay, sewage is sludge, and this sludge is removed by some mechanisms. Okay. Next is design specification of primary sedimentation tank. And the primary sedimentation tank of domestic sewage may be expected to do 30 to 45% removal of BOD. Okay, that is, by this process usually 30 to 45% of BOD is removed, and also suspended solids is removed up to 45 to 60%. 45 to 60% removal of suspended solid is carried out depending on the concentration and characteristics of solids in the suspension. And the secondary settling tank, if considered independently, remove a very high percentage of flocculated solids. That is, after the biological treatment we are doing this secondary settling tank, and it will remove high percentage of flocculated solids, that is even more than 99% under certain situations. So it is more effective, that is secondary settling tank. So next is an important term, that is discharge per unit of plane area is very important term for the design of continuous flow type of settling tank. Okay, so that we have discussed what is continuous flow type of settling tank, and in that type of settling tank the discharge per unit of plane area is known as overflow rate. Okay, that is overflow rate or surface loading or overflow velocity. So it is a ratio between flow rate and settling surface area. Okay, so as long as this Vs, that is settling velocity, is greater than overflow velocity, the particle will settle down for any depth of the sedimentation tank. That is, this is overflow rate, overflow velocity represented by VO, and there will be settling velocity. So when the settling velocity is greater than the overflow velocity, what will happen? The material will, or the organic matter will settle down. Okay, that is one of the principle behind this sedimentation process. That is, decreasing this overflow rate will lead to the settlement of even particle which will be having lower value of the settling velocity. That is, in order to increase the settlement, we have to decrease the overflow rate. Okay, so smaller particle will also settle down if the overflow rate is reduced. If we reduce the overflow rate, we can settle down the smaller particles also. Okay, that's very important principle behind this sedimentation, that is, there is overflow rate and settling velocity. So in order to increase the settlement, we have to reduce this overflow rate. Okay, so how can we decrease this overflow rate? From this equation it is clear that overflow rate can be reduced by increasing the surface area of the basin. So it is therefore follows that an increase in the plan area, that is width into length, that is the area width into length, that will increase the efficiency of sedimentation tank. That is, if we increase the plan area of the tank, it will increase the efficiency. Okay, that is theoretically actually the depth will not have any effect on the efficiency of settlement removal. That is, depth has no role. Surface area means it will be width into length. So when we increase this width into length, the surface area increases. So when this area increase, overflow rate decrease, so the efficiency of the settlement tank will increase. So area will have, surface area have a very much important role in increasing the efficiency. Depth has not much effect. Depth does not have any effect on the efficiency of sedimentation removal. So it is important for practical consideration and also for making allowance for deposition of sludge and silt. That is, we have to increase the surface area. Okay, and usually the effective depth, that is depth excluding the bottom sludge zone. Sludge zone means the area where sludge is deposited, and excluding that area or excluding that portion, usually the value of effective depth ranges between 2.4 to 3.6 meter. Okay, so for design we are usually taking depth of the sedimentation tank as 3 meter. That is, usually it will be varying between 2.4 to 3.6, and in problem if depth is not given, so usually we have to design sedimentation tank. At that case, take depth as 3 meter. Okay, so this is about overflow rate, and the factor affecting overflow rate is surface area. and increasing surface area will increase the efficiency of sedimentation tank. And next point, the depth has no role. Usually depth is taken as 3 meter. Okay. So next, design of rectangular sedimentation tank. So flow velocity is equal to discharge divided by B into H area. Okay. So settling velocity V is Q by area. Area means B into L, width into length. Okay. So this we can discuss by doing one problem. Then another important term which is used in connection with the design of sedimentation basin is detention time or detention period or retention period. It's very important. And detention period of a settling tank is defined as the average theoretical time required for the water to flow through the tank length. Okay, that is from inlet to outlet. That is the time taken for the sewage to travel from the starting of the sedimentation tank to the end. That is actually the detention period. It is the time that which would required by the flow of water to fill the tank if there is no overflow or outflow. And detention period of rectangular tank is equal to volume of the tank divided by rate of flow. That is detention period, volume of tank divided by rate of flow. That is volume means B into L into H. Rate of flow usually we are noted by Q. Okay, rate, that is BLH by Q. Volume means length B into L into H. Width into length into height divided by rate of flow is actually detention time. Okay. And this retention time or detention time usually ranges between 4 to 8 hours for plain sedimentation, and if we add coagulation, this settlement process increases, so that the detention period also reduces. Okay, so at that case, if we add coagulants, detention period is reduced, that is it will be 2 to 4 hours. So for plain sedimentation, detention period will be more than that of the sedimentation with coagulation. That is, if we add coagulation, the process will complete within short period. So detention period will be reduced. So it will be 2 to 4 hours for sedimentation with coagulation. Okay. And the flowing through period is actual average time which a batch of water takes passing through the settling tank, that I told. And the displacement efficiency is defined as ratio of flowing through period to the detention period. That is, there is another term, that is displacement efficiency. Displacement efficiency is equal to flowing through period divided by detention period. Okay, that is displacement efficiency. The ratio of flowing through period to detention period is called displacement efficiency. And okay, so these are some of the factors which is considered for the design of sedimentation tank. So we can do one problem. Design a primary settling tank required to treat a sewage from a town of population 1 lakh. Okay, so here population is only given, other values we have to assume. Okay, and assuming per capita production of sewage, that is per capita production of sewage is assumed as 120 liters per day. Okay, so since population is 1 lakh, the average daily sewage flow will be equal to 120 into 10 raised to 5, that much liters. Okay, so this is per day, it is per day, so we have to convert it into per hour. Okay, so divide by 24 into 1000, so we will get 500 meter cube per hour. That is the average daily sewage flow, that is per hour. Okay, and here we can assume the detention period of 2 hours. If it is not given, we can assume as 3 or 2 hours. So here it is assumed as 2 hours. So capacity will be equal to this detention period into average flow. Okay, that is in the last lecture, in the last slide we had discussed that what is detention time. Detention time is equal to volume by overflow rate. So overflow rate is here given. So detention time will be equal to this volume. Here we have calculated capacity. We have to calculate the capacity. Detention period is given. So capacity is equal to detention period into this flow rate Q. Okay, Q into V. So that is equal to 500 into 2. So that is 1000 meter cube. That is the capacity. Okay. And after that, assuming depth is, so I have told that if depth is not given, it has to take 3 meters. So surface area is equal to this volume by depth, that is 333.33 meters square is the surface area. Okay, so diameter, we have to calculate diameter, that is pi by 4 d square is equal to this much area. So what is d? D is equal to 21 meter. Okay, so this is the pattern how I have to design the sedimentation tank or settling tank. So for that, if this sewage flow is not given, it has to be assumed. Usually it will be given. In this problem it is not given. So take the take average of 120 liters per day. It is per day, so we have to convert per hour. Okay, so and here one important point is, for this settling time we have to take a detention period as 2 to 3 hours. Here it is taken as 2 hours, and if we calculate area, we have to take depth as 3 meter. Okay, so like that do this problem. More problem is in the textbook, so please please try to work out. If you have any doubt, please contact. Okay, so this is about primary treatment of sewage. So in the next so this module is over, third module is over. So in the fourth module we can start with the biological treatment, that is the secondary treatment of sewage. Okay, thank you.